I'd like to talk about electricity generally, if I can, first of all. And to me, as a scientist by background, and not just any old scientist, but a fundamental scientist, a sort of scientist who goes into science because I want to learn about the universe, I think that's a very worthwhile thing to do. My current role is in communication at CERN, so I spent a long time preaching to my community that we have to go out and convince people that curiosity-driven research is worthwhile in its own right. In recent years, I found out that we actually don't have to do that because people think it is anyway. If you do opinion surveys and you ask people, do you know what's inside an atom, they say, haven't got a clue. If you say, is it worthwhile, they say, of course it is. If you ask them how the universe works, they haven't got a clue. Is it worthwhile knowing, investigating? Of course it is. It's part of being human. So one of the things that we're very keen now to say is if you look back in history, anything you take for granted today, anything at all, any gadget you like, be it your mobile phone, your computer, whatever, and you trace it back far enough, there's somebody who was curious at the beginning of it. Now, my favourite example is Faraday, actually, and Faraday is the reason we have electricity. And we don't have electricity because Faraday thought, I want to make this sort of stuff that will make light bulbs and computers and everything. He just saw natural phenomena and was curious about them. And Faraday is very unusual amongst great scientists of the past. Most of them are people like Ernest Rutherford, who famously is misquoted as saying, the idea that you might get energy out of an atom is pure moonshine. He didn't think it could happen. Most scientists don't see the applications of their work, but people are sufficiently creative, inventive, that they always find something to do with whatever fundamental science throws up. And Faraday was the exception because he famously said to Gladstone, who asked him what the value of his work was, "One day, sir, you may tax it." So that's it. That would be, to me, the most fundamental message that I would like to get across about electricity, all the things we take for granted today, is that fundamental research is the driver for it. So to go on to efficiency, though, again, I work in a laboratory, which is a big and expensive place to run. And our tools are called particle accelerators, and our biggest one is called the Large Hadron Collider, and when it's running at full tilt it consumes the same amount of electricity as the domestic consumption of the city of Geneva. That's a lot of energy. It's a lot of energy. I mean, by the time you spread it out across our 20 member states, it's not so much, but nevertheless it's something that makes us think we want to be efficient about using this. So one of the things that we do in the lab is we are constantly driving forward technology that allows us to operate these big machines more efficiently than ever before. So the one that we're in the process of switching on now, so the process switching on one of these machines, is something like 70 to 100 times more powerful in terms of its research reach as its predecessor, but its energy consumption is identical to its predecessor, and that's because we've pushed the technology envelope forward. So that, for me, that's one of the important messages. Another one, when people ask me about what CERN's energy consumption, how green we are, well, the most famous equation in physics, or possibly in science, is E equals mc squared. And what that tells you is the E means energy on one side, and m on the other side means mass, and c squared is a very, very, very big number. So what this equation tells you is that in a tiny bit of mass, there is an awful lot of energy. Now, I wouldn't say most, but a lot of the energy that we use, certainly if you live in France as I do, today comes out of that equation. E equals mc squared is what nuclear power stations do. You take a small amount of mass, you extract the energy from it, and you get a lot of energy to power people's homes. What we do at CERN is we take that energy from the French nuclear power network and we run the equation backwards. So we pump that energy in to create mass in the form of the particles that we want to study. And why am I talking about all this? Because the word nuclear has become a rude word, actually, and not without reason. That what happens in a power station, if you don't moderate it and control it, can make a bomb. And what happens in power stations is that when what you do is you get a great big heavy nucleus, and you split it into smaller things and out that weigh less. So you've converted that mass into energy. But the daughter things, the things that are produced, are a bit tricky to deal with. They're radioactive. They have lifetimes of sometimes thousands of years. You've got to deal with that. And I think it's probably quite fair to say that the nuclear industry embarked on the first wave without really knowing how to do that. But now, energy demand in the world is rising. Renewables are going to help. All kinds of things have got to help. But I think that nuclear has to be part of the equation. And one of the things that I find very interesting, a relatively recent development, came out of CERN actually. One of our previous directors, called Carlo Rubbia, who's a Nobel Prize winning physicist, proposed in the mid-90s that you might couple the sort of technologies that we use with particle accelerators at CERN to a nuclear reactor using a different kind of fuel. And the fuel that he proposed is another heavy element called thorium instead of uranium. The big difference between thorium and uranium is that when you pump a neutron into a uranium atom, you get energy, daughter products, 3 neutrons. That's why, if you're not careful, the reaction can run away. 1 neutron in, 3 neutrons out. Imagine that multiplying up. So in a power station, you absorb all the extra neutrons and you have a controlled reaction. In a bomb, you don't. But if thorium, very similar, neutron comes in, the atom breaks up, daughter products come out. In this case, they're stable, or they have short half-lives, so you don't have a storage problem, and you get 1 neutron out. So the problem with that idea for energy generation is that the reaction isn't self-sustaining. So the efficiency for catching a neutron is not 100%. So after a while, the thing just fizzles out, and you don't get energy out of it. So his idea was build a little particle accelerator, use it to provide neutrons, pump them into the thorium vessel, drive the reaction, and if you get more energy out than it costs to run the particle accelerator, you're in business. You've got clean nuclear energy. And that's an idea that sat around for a long, long time, for reasons that I don't really understand. But now people are starting, in India, I believe, to build prototype facilities that do this. And at CERN, it's a good thing, really. CERN exists, the place I work exists to do pure blue sky research. We are forbidden by our convention from doing applied research, unless there are extenuating circumstances such as there's nowhere else in the world that could do it and it's important, then we make the odd exception. So for this idea, all we did was test the basic ideas, the basic science, and the basic science all hangs together. And when we tested the basic science, we also just thought, well, if we produce this little particle accelerator making neutrons, could we do something about the existing nuclear stockpile? Could we take plutonium, put it in there, pump neutrons into it, break it down into stable things? The answer is yes. Could we use this technology to develop medical isotopes for use in hospitals? By the same technique, putting neutrons into elements, breaking them up into things that are useful in medicine? The answer is yes. So this technology, this idea that came out of CERN, by a particle physicist proposed it, offers you a possibility. There's a lot of R&D to be done, so I'm not going to say it's a panacea or anything, but it's a possibility to have clean, environmentally friendly nuclear energy without the storage problem that helps deal with the storage problem that we've got and provides isotopes for medicine. So to me, that's an exciting development, something to watch. And as I said, I believe it's beginning. The Indian government is beginning to invest in this sort of thing now for very good reason. They have a large population, they have increasing energy demands. They also sit on top of a very large percentage of the world's deposits of thorium, which would be the fuel.
Very, very interesting. As a subsidiary question to our presence here at LIFT, if you were given the amount of the carbon footprint for the LIFT conference, which they've reckoned to be roughly 1,000 Swiss francs, what would you do with that sum?
1,000 Swiss francs, where can you go with that these days? I don't really know, but I know the sort of direction I would like to go in it. And I heard a talk that came just after mine that I found quite inspiring, actually. And the reason why is because this was somebody who's doing at a grassroots level something that makes a real difference. And I'm very sceptical about initiatives that we can make a difference. That by not getting plastic bags from the supermarket, you're going to make a difference. I don't actually buy that. And for a long time, I've been convinced that if we want to make a difference, it's got to come from government. It's got to be something that's driven from above. And one of the reasons why one of the things that reinforce that prejudice, if you like, is reading James Lovelock, the founder of the Gaia movement, who says, I'm going to keep flying, I'm going to use plastic carrier bags because too little too late. We can't make any difference. We're headed for a catastrophe. But I'm optimistic because human beings are best in crisis situations, so it's only when we get there that we'll find our way out. Now, that might be a bit depressing, but it sort of resonated. But there was somebody there saying, by doing very, very small things, like putting little patches of greenery in front of fire hydrants, you can really make a difference. So that's a nice initiative. So I'd like to invest this money in something that's producing grassroots initiatives that can really make a difference, not like just swapping your plastic carrier bags for one that lasts 10 trips to the supermarket instead of one.
Do you have any particular grassroots initiative in mind?
I don't really know. I mean, I liked her. I'd give it to her. Why not? Give it to her environmental health clinics, because I think that's a lovely concept.
A grassroots initiative for environmental health clinics.
Yeah.
James Gillies, thank you very much.
Pleasure.